Welcome to the Duke Learns Things podcast. Where the heck do mountains come from? Why are diamonds so hard? And is salt the only material with a strong flavor? Today we're learning about geology, and I'm here to ask the real questions about everything from pebbles to pyrite to pyroclastic flow. So get comfortable, because it's time to learn some things. As my hotkeys don't work. Beautiful. All right. Hello. Hi, Sage. Are we good?
Yes, we're good.
Beautiful. Everything works beautifully. Sage, you just talk a little bit, and everyone in chat let us know how the levels are. But yeah,
Talk.
welcome to the show,
Hey, guys.
Sage, and welcome to the show, everybody in chat. And again, thank you all for the follows. Everyone that's coming early, you guys are the best. This is the Duke Learns Things podcast, and we're joined by RockitSage. So hello.
Hi.
All right. So, for those of you who don't know, Sage is a geologist and university instructor. So, kind of the perfect guest for the show. So, Sage, if you want to tell us a little bit about yourself before we get into it.
Sure. My name's Sage, or RockitSage, as you probably know me. I'm a geologist and a streamer. I play a variety of video games as well as scream about rocks and volcanoes and earthquakes and all sorts of climate issues and whatnot. So feel free, to ask questions whenever Sir Duke says it's okay. I love the earth sciences very, very much, and I love teaching at the university that's local to me as well.
Which, yeah, I was saying before, and I'll repeat it again, kind of the perfect guest, because not only do you have a wealth of knowledge about a subject that I know literally nothing about, it's your job to teach it to people, and on
Yeah.
top of that, as a content creator, we're in that same realm. A science communicator on Twitch, part of the Knowledge Foundation,
Yes.
Knowledge Fellowship?
Yes.
Knowledge
Knowledge
Fellowship.
Fellowship.
Yeah.
Yeah, we founded that in, I want to say 2017, and it just houses a bunch of educational content creators. Tons of different topics.
And we were
It's
talking about
crazy.
beforehand that we might potentially try and get some of those on the show as well, which some
Hmm.
of the other members, which would be incredible because, again, people also science communicators like yourself. So, hopefully willing to share a bunch of new things for me to learn. So that would be fun as well.
I'm sure they
Um,
will. They're very, very
how
friendly.
how are you, by the way? Because we had to
I'm doing
postpone
good.
because you were recovering from COVID, which was just the best timing. Um,
Yeah. So I'm still coming off of that. So I might sound a little bit weird or look a little bit tired, and that's really the only reason why. It's just because I think day 9 now. I'm almost like recovered, I think. But even when the symptoms are gone, I still have to take a test and make sure I can go out and about and do things again.
yeah. I think I've managed to avoid it throughout the entirety of the pandemic, but that's mostly because I don't leave the house. So
Yes.
that helps. But yeah,
I
that.
blame Magic the Gathering.
Oh yeah. You went to like a tournament or something, like a.
Yeah, I just wanted to play Magic cards. I just wanted to play Magic. Oh
Do
man.
just humor me here. Do Magic the Gathering tournaments smell as bad as people say?
Well, I can't smell anything right now.
That's
But
kind of a
yes, actually,
blessing.
they are pretty bad. Some of them are real bad. The last one didn't smell at all, and it was bigger. The one prior to that, or at a different place, was pretty smelly.
Oh god. Um. Yeah. Before we get into sort of just straight up rocks, as much as we love rocks, Um, how long have you been I guess studying geology in general, and how long have you been teaching it?
I've been studying geology since I was, I think, 18 or 19, and I'm 36 now.
So
Because
almost
I'm
half your
old
life.
lady. Yeah, basically almost half my life.
Yeah.
Good God. I did take a break for a few years because I did double major in religious studies and geology. And then I got an NSF grant for my master's in geology. And I'm like, I'm not walking away from that. I love this stuff. And I just constantly worked in the lab. And at the very end of my master's, my advisor was amazing. I could not have had a better advisor. And he was basically on his way out the door. He was going on sabbatical or retiring. No, he was retiring, but he was on a 6 month sabbatical and he was gone ice climbing for 3 months.
Oh shit.
And I was just waiting on my edit of my thesis to graduate. So I was just kind of chilling, working the SEM lab because I ran that for people. And then I was asked if I wanted to teach something. And I'm like, yes, I don't have TA experience. I need that for my PhD. Please, I would love some teaching experience. And it just so happened that I kind of just fell in love with it. And I did start my PhD, but I came back to continue teaching. I
So
fell in love with it.
just a complete sidetrack. What do you do in a geology lab?
Just depends on the lab. I mean, we've got a cold storage room for lake core sediment. Like you actually, they're they're core that are like circular in shape, and so they drill down into old lake sediment and then pull that lake sediment up. But
Right.
you have to keep it in order in the same exact um, way. Essentially, you can break it apart into pieces, but you still have to keep it in order. And then they put it in a refrigerated cold storage room, and that's one of the areas. And we've got another area with a scanning electron microscope that has literally an electron beam just shooting its samples in a vacuum. And that thing's
Yeah,
a
that's
half
where
million
you
dollar
see like
machine.
really, really, really tiny shit, like
It's
molecular
200,000 times
level.
magnification.
Okay.
You can see three-dimensional figures, or you can look at the chemical composition of things. And I love that thing. Then there's rock microscopes, which we call petrographic microscopes, and they polarize and cross polarize the light so we can see various things in extremely thin cut rocks on thin section. I mean, I'm talking like 20, 25
Nanometers or
millimeter
oh.
um, um, micrometers thin,
Mm.
typically.
So
Not nano. Nano would be too thin.
yeah, nano is like really, really, really small.
Yeah.
So okay. Again,
There's a
I'm
bunch
just
of other
gonna
stuff too.
just follow this derailment. You drill a big what cylinder out of a lake bed
Yeah.
and
Yeah.
then
You
put it in a
basically push it
fridge.
in, and it's not really that deep, but yeah, you refrigerate it to keep it dry and to keep it intact.
So is this
Usually they're
like
wrapped.
you take it over like a series of time to see how it changes,
Hmm.
or like
Hmm.
just looking into the composition of it?
Both. So you would look at it. That's why you want to keep it in order because the
Right. So
topmost layer
yeah,
is going to
right.
be the
Okay.
youngest. And you want to keep it all in order. Even if you break it up, you know which is the end of each piece and where it starts again. And then you look at things like pollen. Typically, those are used for climate stuff. So you look at the various types of pollen in the lake to get a proxy of the climate changes in the area.
Oh man.
It's pretty dope.
Just get into the climate change real quick. I was saying earlier, it's really, really warm today, and
Yeah.
something sort of sparked my interest like a couple days ago that basically said, and we're not going to get all into like the whole climate change of it all, but I read something that essentially said that heat waves are going to be getting like earlier in the year
Yeah.
because of climate change, which sucks, and we're feeling it here in the UK because we don't have AC or anything. So,
Mm-mm.
okay, we'll talk about going up by this example specifically. What do you look for in say the pollen or just like the composition of sort of samples that you would take from a lake that would indicate climate change? Like what about
So
that composition is kind of indicating changes in
a
climate?
really easy example is to compare, for example, grass pollen species versus forest or pine needle pollen species. So pine trees tend to grow in very cold environments, and grass tends to grow in warmer environments. So that's just a very kind of blanket, easy example. So basically, you're comparing two different species
Yeah.
of pollen in the core to determine, okay, during this time it was primarily pine needles. During this time it was primarily grass. During this time, pine, grass, et cetera, et cetera. And then you figure out the length of time that's actually surpassed based on maybe carbon that's in your samples, or you can just determine it based on a variety of other features and correlate it with other studies globally to get a really good match. And typically, there was one lake done out here called Tulare Lake that is a dry lake bed now, which is why we can get the cores. And we've actually matched it up to several global lakes. And this type of work, this pollen counting is what it's called, isn't actually anything I did firsthand, but one of my best friends did a lot of this work. So I was right there with her while she was doing hers. Meanwhile, I was doing SEM work on old oil reservoirs to determine whether or not we could pump CO2 into them to mitigate climate change. So we were kind of
Right.
working simultaneously in the department. There were groups of students working on modeling climate, which is what the pollen does, and there were groups of students working on mitigating the changes of climate in the future. And it was a really good department. It was really, really fun. And it is a good department still.
Not to get like doom and gloom from the
Oh
jump,
yeah, no.
but like being in that kind of work with the direction that like basically sort of every scientist is saying the direction the world is going? Is that scary? Like, especially when you're sort of measuring, say, like the rates, or like your friend was doing, or you're looking at mitigating. Like, do you start to kind of see that? I mean, is it optimistic? Do you see that there are big changes that we can make in that field that are going to help a lot, or is it like, oh, this problem is a lot worse than we thought?
Yes and yes.
Oh, great.
It's very scary. It's very scary. I still very much remember being in my bachelor's program. We're currently at over 400 parts per million of CO2 in our atmosphere.
Mm-hmm.
Normally, the baseline is around 280. The natural world changes in climate because climate changes naturally
Yeah.
all the time, and it has in the past. It usually fluctuates around 280 parts per million, up and down, but it always kind of averages around that. We surpassed 400 parts per million. We're currently above, I believe, 415 parts per million. And I remember sitting in a classroom. It was a junior or senior level course. Maybe it was structure or something. I don't remember. But I just remember the professor stopping everybody, and we were going over the CO2 atmospheric parts or the amount of CO2 in the atmosphere, and it was at 390 something. And he's like, I dread the day that it surpasses 400. And here we are sitting at 415. And I'm like, ouch, that memory will never, ever go away out of my mind. So it is scary. But I've also worked on a variety of methods to try to mitigate that. And yes, I do think that there is a chance if people give it the chance.
Yeah.
That's the thing. And that, and we need to share the information about the solutions with transparency, not just pretend that they're all golden magical solutions, because nothing is perfect. Everything has pros and cons.
There's no silver bullet to
No, but I
climate
think
change,
with
because
all these different methods,
there's
we've
also a
got
lot
a
of
chance.
contributors, right? It's not just
Yes.
there's not just one thing that's going to fix it all. But yeah,
No.
so I mean, when I asked sort of initially when we were sort of getting the plans for this together, and I said sort of what's your specialty right now in geology, and you said that right now your sort of research study primarily was in I guess like assessing old oil wells,
Yes.
for want of a
Yes.
better word, and just seeing basically how much CO2 we can squeeze into one of those bad boys.
Mm-hmm.
So like I'm sure there's a wide range, right? But I mean, oil wells must be freaking huge, right? I mean,
It just depends on the oil reservoir. I mean, basically in the early 1900s when people discovered oil out here, they just kind of, a lot of it was high pressure, such that you could just kind of tap into the well and there were a lot of gushers
yeah,
back then. And they aren't really existing anymore because we've basically tapped into all of those. Some of those superficial wells may have been pretty small, but since then they've done a ton of oil exploration out in Texas, California, the Dakotas, where they're fracking a lot, and they've for the most part found most of the giant oil reservoirs. I don't know that there's much in the way of exploration left. Most geologists that are hired into oil are for um, production, not for exploration. So two different
yeah.
geologists, kind of different kinds of jobs. So now they're working on getting more oil out of the reservoirs, and that's typically what the geologists do instead of finding new oil reservoirs. Yeah, that's basically all there is in the Dakotas, the Bakken Formation.
Lots of oil,
It's a it's a extremely impermeable layer of oil-rich rock that they have to frack to get the oil out of because it just doesn't flow otherwise.
which is blasting gas down and forcing the oil out. How does fracking work?
So they drill a pipe like you would in any oil situation. So they
Right.
drill a pipe down, but then they'll often drill horizontally into a layer that is extremely difficult to pull any oil out of. It's impermeable. So maybe the spaces where the oil exists aren't connected, so they can't flow out.
Right.
So they drill into this layer horizontally, and the pipe is perforated. So there's tons of little holes all throughout the pipe, and then they pump this mixture of water,
Oh, right.
sediment, and a variety of just materials, some chemical substances, and just shove pressure via water and sediment into these perforated holes through the pipe, thereby cracking the rock open, and then they allow for oil to flow. So the fracking process, as well as the pumping of materials down into the earth itself, that that increased amount of pressure is what's causing the hydraulic, or what's causing the induced earthquakes. But all of the oil industry actually causes induced earthquakes just by drilling wells and pumping induced or wastewater back into reservoirs.
Yeah, I think it's there's always that sort of hesitation where, oh, we've been drilling oil for like literally a
Mm,
century, but fracking is kind of this seemingly like newfangled method, and people are very
yes.
sort of hesitant to just jump in and start blasting rocks apart with
Well, and it makes
high
sense when you
pressure.
all of a sudden are they're drilling in an area they hadn't drilled before because they
Yeah,
found out that they can frack all this material and you're suddenly experiencing induced earthquakes out in Oklahoma. That's scary.
yeah.
I can imagine why people would be upset about it.
So to go to go back, I just back to the sort of filling old oil wells with
Hmm.
CO2. How do
Yeah.
you harness CO2 from the atmosphere and then get it down there and keep it down there?
There are multiple ways that they're working on. There's direct air capture, which is quite frankly very expensive. So they basically there's a if you want to look it up, Orca, ORCA, as a program. I think it's in either Iceland or Sweden or Norway or something. I can't remember where, but somewhere in the Scandinavian part of the world. And there's it's called Orca. They basically have these giant fans. They're like 3 fans high, and I don't even know how many fans wide, but they basically directly capture the air, filter out the CO2, and then they would either pump it into water to carbonate it, like in the case of Iceland. So they just pump carbonated water into the ground in Iceland. And the rock just happens to have a ton of calcium in it because of all the volcanic activity there and the
Oh,
type
okay.
of rock that's made. So what happens is the CO2 that's pumped in there in the carbonated water bonds preferentially with the calcium, creating a beautiful long-term mineral that will stay there for millions of years. So that's the best case scenario. The direct
Right.
air capture portion, however, is expensive as fuck. Excuse my French. It's expensive. It's very hard to filter out specifically, I don't know, just the CO2. And I assume that maybe they're working on the nitrous oxide and the methane and the other greenhouse gases. There's 6 major greenhouse gases that they're concerned about. The methane, the nitrous oxide, and the CO2 are the big three, though,
Right.
that most people know about. So it's expensive as fuck to get the direct air capture. But there's another method. You can actually just directly capture from factories that are producing a lot of CO2, refineries that are producing a lot of CO2. So instead of all that stuff coming out of smokestacks, and by the way, when you see a documentary with a smokestack, 99% of the time it's water vapor. Big, like
Yeah,
cloudy poofs,
the
water
the
vapor.
big
They're
cooling
just
towers
dramatic.
is like always imagery of
It's so
dramatic
silly.
industry, but it's a lot of
You
the
never
time water
see the
vapor.
CO2.
Yeah.
Anyway, so they directly would just, instead of letting it out into the atmosphere, capture it. And in this method, what they would do is turn it into a supercritical fluid, which is not just a fluid, but it's a fluid that's under immense amounts of pressure, such that it is called a supercritical fluid, and it must be kept under high pressure conditions, which luckily those oil reservoirs are under high pressure conditions. Because,
Right.
well, why? There's so much rock on top of them. They're in the ground. So they're surrounded by
Yeah, same sort
pressure,
of reason
both
that when they were first tapped into, you got, fountains
gushers.
of oil. Exactly,
Yeah,
right. So you just
exactly.
shove CO2 down there instead, and it'll be in
And
that
it
high pressure environment.
Yeah, and
So,
so ideally, as a supercritical fluid, it shouldn't leak. So there are a series of requirements the government in the U.S. has for that type of CO2 sequestration.
so that it's not going to explode or some other
Ideally,
how. Yeah. Okay.
but they've only got it to last for about 1,000 years, which isn't very long.
Yeah, but it's one of those. We'll all be dead by then. They can figure it out down the line. Um, well, okay.
Hopefully,
So obviously that was
I know, I
fascinating. I'm
know, I
I'm
know,
really
I know.
glad to be able to just kind of like cherry pick one tiny thing and just delve
Yeah,
into that. That's beautiful.
you can
Yeah.
ask
Well,
whatever. I don't
well,
mind.
yeah. To completely change pace, is salt the only rock that tastes good?
No,
Or rather
depends on
that
what you
has a
think tastes
flavor.
good.
Okay, that has a flavor. I mean, of course, we
I
know like
mean,
sulfur smells bad, right? Like that's
yes. That's a pretty easy
does it
one.
taste
I mean, I
bad?
think almost anybody could. I don't know. I've never licked it.
Can you lick
I
it?
imagine 70% of your taste is smell, so it's got to be nasty.
Yeah, but like,
Gotta be
I don't know,
nasty.
coffee tastes worse than it smells. So like, what if
No,
sulfur
I
tastes
love
better than it
my
smells?
see this coffee
Yeah, okay, but
because
how
it's
much of that
delicious.
is like sugar or you know, or like if you just take raw. Listen, I feel like most people could agree coffee smells great, but not everyone likes the taste of just black coffee. So maybe sulfur
Maybe you've not had
smells
good
really
black
bad.
coffee. No, sulfur. I have no idea
You know
how
they make
sulfur
coffee out of
tastes.
cat poop. They're like
Shut
they
up.
just yeah, they have there are these
I
cats
will
they
not
like
eat the cat
eat
poop.
they eat the beans and then they poop the beans and then they make coffee with the beans.
Out of cat poop?
Well, like the beans themselves, like the actual coffee beans are eaten by cats and then pooped out. And then I think they treat them and roast them, but there's like I guess it goes through some kind of process in the digestion of the cat that like makes it delicious somehow. It's really
Does it kill
expensive.
the toxoplasmosis so you don't get those brainworms that make you want to be a crazy cat lady?
I mean they roast them and stuff, so I'm sure that's fine. $400
Oh
a
my
pound
God, I have so many
apparently
questions.
for the cat poop coffee. I can't answer too many questions about cat poop coffee. I just know it's a thing.
How did this turn into a cat
Jeez.
poop coffee stream?
So okay, I'm gonna get this wrong. Sodium chloride.
So halite or table salt isn't the only mineral that has a salty or different taste. It's one of the easiest to identify because of its cubic shape naturally and its salty taste. But there's another mineral called sylvite, and
Okay.
sylvite looks like halite often, but it has a bitter, bitter, salty taste. So that's actually one way you would differentiate the two.
Like worse,
Um,
so or like I guess like really
it's
off-putting
just
compared to salt's
I
like
think it's
pretty
off-putting.
neutral.
I've never actually tried it. I've just actually heard that it's a real bitter and salty taste, and it's extremely easy to differentiate. Most minerals really just don't taste like anything. Like I've kind of in my early career, I would try to lick
Licked a
like
lot of
quartz
rocks.
and yeah, and they don't really taste like much unless there's dirt on them, I suppose. Then they might taste a little bit like dirt. We do put dirt on our teeth to in the field, and this is a weird one, I know, to determine the difference of grain size between clay and silt, because clay and silt are the smallest, and you can't differentiate them with your eye, but you can feel grit of silt on your teeth and not of clay. So we do that sometimes.
Just
We don't eat the dirt. We just
but
put
you
it on
rub it
our
on your
teeth.
teeth between silt and clay specifically. You're like, oh,
Yeah.
that's really gritty. I guess that's silt. Yeah,
Shut up, Muga.
that's an that's an interesting practice. Okay. Next little just random question. This is for the sake of my own curiosity. What is it that makes a mineral translucent versus opaque? Like what quality is it?
Impurities. Impurities typically, or if it's a metallic mineral. So anything that is considered metallic, and what this means is basically metallic minerals are so shiny that they reflect basically all light back. And this is kind of a difficult property to imagine because you can imagine that there are a lot of impurities or imperfections on the surface of a mineral. So you might have pits and grooves that affect the reflectivity, but it's still going to be extremely shiny. And sometimes you might have oxidation, so it dulls and things like that. But they're on the thin section scale still going to be opaque. And they're
What, so something like a really like pure quartz, for example,
quartz is not a
is
metallic, so that
right.
one is just SiO2, right? Silica and silicon and oxygen. And if it's pure, if there's nothing in it, like for example, and let me show you a couple of
Oh, the
things.
rocks are coming out. Here we go. For anyone on the audio only version, Sage is going to grab a rock right now.
So these are all types of quartz. They're all different colors.
Multiple rocks.
And this is one of the reasons why I think identifying color or identifying a mineral based on its color is a very, very bad thing to do. And there are specific exceptions though, like malachite and azurite are pretty easily identifiable based on their luster and their color. But typically, this is just clear quartz, right? It's just silicon oxygen. There's really not any impurities in here such that it's going to be opaque. Um, Anytime you get an opaque type of quartz, there's going to be impurities. So here I've got some smoky quartz,
Okay.
and there's some of the clear quartz at the bottom, but this means that there's a little bit of iron trapped. In fact, Both amethyst and smoky quartz have iron in the crystal lattice trapped, but it's negligible. It's less than 1% of the mineral, so
But
it's
enough
not
to
included in the
change
chemical formula.
its appearance
Yes,
pretty considerably.
just enough to change its color. So the iron in this amethyst and the iron in this smoky quartz have been exposed to different amounts of heat, which is why the smoky quartz is kind of a gray and this one's purple. And then you can have hematite. You can have other minerals actually as impurities in a different mineral such that it turns an opaque red. This has hematite in it. It's an iron oxide.
So that's
And it's,
like quartz plus iron oxide, I guess.
well, it's still considered a quartz, but it
Yeah.
does have a name. It's a German name that I always forget. In English, we call it ferruginous quartz because it's iron rich,
Right,
but
yeah.
it's still quartz.
And
It's
there's no
just
way to
colored
like
red.
extract the iron from something like that. That it's just completely like bonded in there.
You wouldn't want to because it'd be negligible amounts.
Right.
I mean, you wouldn't be able to get very much out of it. You may as well just mine hematite, which is what they do.
So you said quartz is just silicon and oxygen,
hmm It's this.
right?
This is
So
the
which I
component
mean,
elementally.
glass is what?
It's a lot of silicon, if I remember correctly. Material science is really
Like
awesome.
yeah, like household glasses is also it's just at least as far as I know silicon, right? Because it's like sand. In every video game that I've played, you take sand and you put it in the furnace and you get glass out. Like I'm sure that's how it works in real life.
It's very silicon rich, yes.
Yeah. So
But they can put other stuff in it to make it harder or a little bit different.
like
I
and
mean, there's
temperate and
different
things like that.
lusters on different kinds of glass for museum materials and things like that. And I don't know what all the little elements are that go into each of those,
Okay,
but I know they're extremely interesting.
this is a weird question.
Mm.
A little bit of it's just something popped into my head. So old this might apply to all glass, but I could be completely wrong. Is okay. Something about glass being fluid. Okay.
Oh,
Is
glass
this
is amorphous.
okay?
So
Because
it's a solid, but it's an amorphous solid.
we have some really old churches in the UK, for example. The windows, there's like, oh, the oldest stained glass window in Britain or something, it's like 1100 years old. They end up like thicker at the bottom over
So
time.
I'm gonna burst your bubble. That's actually a myth.
That's a myth?
Yeah.
Okay, bust the bubble. Now I'm excited.
Okay. Glass is actually very amorphous. It's an amorphous solid, but it does not flow fast enough to get thicker at the bottom of those windows.
Even over a
Instead,
thousand
what happened?
years.
Yeah.
Okay.
Maybe you might see some negligible changes over 1,000 years, but none of those windows I think are even that old.
Yeah, I'm pretty sure. I'm pretty
They might be,
like I
but
could be wrong.
it, I think it does take quite a bit of time.
Yeah.
What actually is the case, what they found out is it's the production of those windows back in the day was not perfect. So they were
Right.
often variable thicknesses. So they would put the thicker parts at the bottom, I think because it was more stable.
That makes sense. I'm sure there's some, I don't know, ancient Norman turning in his grave or something that you're talking shit on his
Yeah,
glass making practices, but
I
that
know,
also makes
right? They're all angry.
more sense.
But no,
Um,
I believed the same thing for a very long time that glass was just flowing like that. But I read a paper about it and glass can't flow that
damn,
fast.
damn.
Yeah.
So, what does amorphous mean exactly?
It means that there aren't any bonds in in the material that are keeping it technically it has no crystalline structure. It has no internal structure whatsoever. So nothing is really bonded in any specific way. It's kind of all haphazard and basically the same in every direction, and it allows everything to kind of just flow. It's the same with obsidian. Obsidian cools so quickly there really isn't any time for an internal structure to form.
That's really interesting. Excuse me.
hmm Yeah, I think
Okay,
so.
what contributes
So
to how like brittle something is? Because glass is obviously very like really brittle and shatters easily.
that's such a good question. That actually just has to do with bond types.
Okay.
It just has to do with what kind of chemical bonds are bonding those elements together. And For example, diamond being as hard as it is because it's all covalently bonded, and covalent bonds are the strongest bond type in chemistry that we
Right.
know of. And so let's talk about graphite in your pencil for a second. It's the same chemically as a diamond. It's the exact same stuff. It's all carbon.
Carbon
Diamonds are extremely
crystal
hard.
lattice something.
Yeah, it's just carbon covalently bonded in all directions in the
Right.
case of diamond.
Yeah.
Now you have graphite. Imagine two-dimensional planes of graphite all bonded together in these little hexagons, and it makes a
Hmm.
sheet of hexagons. Those sheets are then bonded together on top of one another, but instead of covalently bonded, they are bonded very weakly through forces called van der Waals.
Oh
And so they
man,
break very easily, and that's why we can write with a pencil.
I'm having like flashbacks to like my first college year of chemistry that I flunked, by the way. But
I'm a
like I can
geologist, not a
see,
chemist.
yeah, but I can like see the hexagons of carbon and then like a
I think it's
dotted
such a cool
line
example. Hmm.
joining and I'm yeah. So diamonds just have like a very just they're all covalently bonded on like all possible angles for I guess for
Hmm.
want of a better word. But yeah, I remember I remember chemistry learning about graphite.
I love
Okay,
chemistry.
if you one of my sort of very specific like interests that I often get taken away with is nuclear physics. So I know this isn't your
Ooh,
field at all, but
but I love
why,
it.
if you can answer this, why is graphite used as the control rods in nuclear reactors specifically? Could you?
I should know this. I think it has to do with neutralizing. Fuck, I don't remember.
It's
I don't
perfectly
want to
fine
give
if
a
you
wrong
can't.
answer.
We're just talking about graphite, and in my head, I'm like, oh man, like it's always
I know
graphite
they are
control
used
rods.
as control rods in uranium reactors, but I don't
Could it
think they're
be
going to be
okay?
necessary in thorium ones, if I remember correctly. And this is all off of just my top of my head memory. So please look up anything about physics and nuclear. I'm not an expert in
I'm
that
just
field.
riffing here.
Oh,
But
that's fine.
could it be to do with the fact like maybe this will jog your memory? I'm completely making shit up. So the way that the carbon is bonded in those layers, could it be that because there's some kind of free, not free electron, but because it's not bonded completely, the
No,
whatever's flying around in the reactor is going to bond to that instead, or is just completely unrelated?
I don't know. It could be.
Okay, fair enough.
I mean, it has to
Any
do with. Yeah, I just don't know. I wish I knew. I'm sorry.
no, that's fine. That's
It's such a good
we
question.
got onto graphite, and I'm like, oh well, while we're here, but yeah, it's completely not even what we're here to talk about. All right, and one other thing, little kind of viral video I saw about bendy rocks. Okay,
Oh, I
what's the
have
deal with
one,
what's the deal
and it was
what's the deal with
expensive.
bendy rocks? As Sage goes to find a bendy rock,
It's
you
my
guys might have seen
flexible
this, but
sandstone.
yeah, okay. Oh
Bends.
God, that is weird. But
It's very
why?
bendy, but I have to be very careful with it. Now I can hear you again.
Okay.
Sorry.
What's so okay? Can you tell us what's going on in there?
Yeah, it's a sandstone, and it's filled with a particular mineral called mica. Um, Here's a big piece of mica.
Oh wow.
Mica is it can be muscovite, biotite, phlogopite, lepidolite, uh, chromite, or not chromite, the chromium bearing one I forgot the name of briefly, but fuchsite. Anyway, they form sheets, very, very thin sheets atomically, and it's kind of similar to graphite in the way I explained it. So they're bonded very well together in these sheets, but they peel extremely easily.
Yeah. What? It looks like peeling paint, kind of.
Yeah, it is, and these are very sparkly minerals. They end up in makeup often, but this particular rock is so filled with mica that it actually is able to bend.
That's bizarre.
I
Someone said
know.
you
When
had
I
two.
found
You
this,
didn't break one, did you?
did I break one?
No. Well, someone in chat said you
No,
had two. So I'm like, oh god.
I did. No, I did not. I don't break them usually. Just sometimes. This rock was so expensive, man. I found it. I'm just like, I need this in my collection. I've wanted it for so long. And then I
Dare I
found
ask
some.
how much? Is it?
I don't remember. I just remember it being expensive to me at the time. I think it was like $30. I mean, for a
Which
rock, that's kind of not cheap.
you know, yeah, for a rock,
Well,
that's pretty expensive.
let me put this away really quick.
Especially, well, so anyone who's listening to the audio only version, the sandstone itself looked completely like unremarkable. The mica that is apparently in it really looks like, yeah, layers of plastic, like, or
Yeah.
if you've ever seen peeling paint on a build on like an old wall, like you could just peel the layers right off.
Yeah.
But yeah,
There
it
might
looked
be mica in old paint.
it looked fairly
I know there's
unremarkable,
lead. Yeah,
but it's a bendy rock. That's yeah,
it is. It's
and
just
it's
and it's super super sparkly up close because of all the mica like little pieces of mica in it.
I can't
I think
imagine.
it's cute.
And you mentioned micas and makeup. I mean, it's kind of
Hmm.
it was like a bronze sort of color.
Just depends. I mean, there's greens, purples, browns,
Oh,
clear, various shades of like browns.
well, okay. We talked about, I guess, transparency. So what changes
Hmm.
the color? I guess it's impurities again with the
Yeah,
iron.
impurities. Well, there's a few ways in which color happens. You can have impurities. You can have, like in the case of sapphire, it's a blue color because it has to do with the iron and the titanium exchanging electrons, and then the release of energy is what we see as blue. Um, and I
Wait,
don't remember the
so
third method.
was that in a sapphire?
Hmm.
Iron and titanium.
Corundum, yeah. Yeah, iron and titanium are in sapphires that makes it a blue, but you can have sapphires that are all sorts of colors. If it's just aluminum oxide, like corundum is, because it makes rubies, it makes sapphires, it makes really beautiful colors. But if it was pure, it could potentially be clear if it was just
That's
aluminum and
so
oxygen.
that's so strange to me. I don't know what assumption I made. I knew diamonds were carbon, but in my head, like
Hmm.
I don't know things like precious gemstones and stuff. I just kind of imagined they were like ore in a way, like they were just their own thing. But I guess it makes
Yeah.
sense that they're
So yeah,
comprised
they're
of
very
different minerals.
yeah. And some minerals can make multiple gemstones. Like corundum makes rubies and sapphires. Rubies are red because of the chromium as a impurity within them. In fact, I've seen people um I've seen people make rubies in their microwave. Don't do this, by the way. You have to have a variety of different like crucibles and things to do this, and
Take notes,
the
chat.
rubies aren't. Oh, what's
Learning
that?
how to make precious stones. Everyone take notes.
Oh yeah. No, it's weird, but the thing is I don't know if it has because it cools so quickly. I suspect it's not true ruby because if it cools that quickly, there's no time for a structure to form. So that's my theory.
What is the method here?
But
Not to go full Heisenberg, but how are
he just
people
like
making microwave rubies?
he mixes aluminum and oxygen, little sand pebbles, I think, and he puts a little bit of chromium in there and he microwaves it, if I remember correctly.
Just a bunch of rocks in a microwave.
Yeah, and he
That's
puts it
gotta
in
be
a little
fake.
crucible. Or that or he put it on a Bunsen burner or something maybe. No, it
That
was it was actually legit.
that sounds like one of those things where someone like breaks their iPhone screen and then they put it in the microwave to fix it, and then you have like dozens of people putting.
No,
Oh,
no, no. It
to
was
charge it. You remember that? Everyone was
I
trying to
do
charge their iPhones
actually.
in the microwaves.
Oh, or turn off the don't be tracked by the government. Put your phone in the microwave, guys. Yeah, that kind
Yeah,
of shit.
kills the. I can't. I feel like I can't go on record saying it kills the tracking chip. So for all intents and purposes, this
Yeah.
is a joke. But
Yeah.
yeah, man, that was people believe anything.
Yeah,
People
they
believe.
they,
Can you
they
believe this?
do.
People believe glass is liquid and flows in windows. It's unbelievable. Some of the things people believe these
We
days.
actually thought that was the case though. A lot of
Well,
people
yeah, I
did,
know.
or that's what they thought for a
I'm
long
just making fun
time.
of myself at this point. I
Oh no, I barely learned that recently.
we got some. I mean, someone said in the chat that English primary school teachers are kicking themselves after that one, and I feel it, man. Like I really believe that
There's
really old window had flowed down to the
I did
bottom.
too. I did too for a long time. And then I
Well,
learned the glass just doesn't flow that fast. I'm like, what? This is bullshit.
so before the stream started, we were talking about a recent earthquake.
Oh yeah. I
Um,
need to check that out.
a pretty a pretty bad one. I imagine you'll probably be looking into it on your own stream at some point. Um, something that especially geology wise, it's always interested me is plate tectonics. Okay,
Mm.
and I guess oftentimes plate tectonics can result in earthquakes and mountains.
Yes,
Um,
they can.
so I don't know okay, where where does a mountain come from? First of all, to call back to the intro, what makes a mountain?
Oof. I'm just looking at this earthquake really quick. It's bad,
Yeah, no.
guys. Here's a link if you want it. I'll just send it to you, Duke.
Mm,
But what makes a mountain, it depends on the tectonic regime. There are several ways in which tectonic plates can interact. So you can have collisional events, and that's essentially what you need for a mountain to form, or rifting. You can have mountains technically form because of volcanic activity. So let's focus on collision first.
okay.
Let's say you have two tectonic plates crashing into one another. As long as one of those is oceanic, so you have an oceanic piece of crust. Oceanic crust is thin, it's dense, and it will always sink in the face of a continent. So the continents are buoyant and thick. That's why they're partially why they're above water. It's partially just because of what they're made of. So you have a collisional event. The oceanic plate sinks, and it drags with it into the earth a ton of water, which then lowers the melting temperature of the surrounding mantle, generating melt because the mantle isn't fluid. It's a plastically deforming solid, so it's kind of like a putty that moves on the scale of millions and millions of years.
Okay.
And but with a little bit of water, because it's under so much pressure and heat, it suddenly is like, oh, chemical reactions, yay, I'm going to become liquid now. And then a little bit of melt develops above the subducting plate. That melt rises because it's more buoyant than the surrounding stuff that's cooler, and it pops up like little pimples, creating a chain of volcanoes along the subduction zone. So that's how volcanoes can form, one way in which they can form. You can have hot spots too, which we're still not sure why they happen. We know how they happen and what, like the effects of what they do, but hotspot volcanism is a very weird thing that is still misunderstood. We don't fully understand why they originate in the first place. And
That's
then
honestly a little
just to get
scary.
a it it's not scary because we know how they behave
Mm,
and we know what they're going to do as the plate continues to move. A new volcano will eventually pop up. It's not too horrifying, and it's usually, well, it's not always an oceanic crust. Like Yellowstone is on a hot spot, for example. There's no tectonic regime feeding that volcano.
right.
So that one's a bit, that's the only outliers is the volcanoes that are made because of a hot spot, like Hawaii and Yellowstone. And,
Oh,
well,
interesting.
Iceland. Mm.
So
Hawaii, Yellowstone, Iceland. There's so many more too. There's
yeah.
there's an abundance of them.
So hotspot volcanoes, they aren't along the essentially, I guess, the lines where the plates kind of meet, but your
That's right.
average volcano kind of is, but we
Yeah.
don't. Okay. So
Especially if you see chains or rows of volcanoes like the Cascades
yeah.
or the Appalachians, then something big tectonically happened to make that. If it's a
How
smaller little chain of volcanoes, then it might be a hotspot.
what sort of time scale are we talking about for like the formation of something like the Cascades or something like I'm assuming millions of years.
Yes. Hundreds
How
of millions, maybe 50s of millions.
do we know how
Yes, we do.
fast the plates move?
Yes, we do. They move at about the rate at which your fingernail grows on average.
That seems
That's
like a
on average,
lot.
though. It is kind of, yeah. I mean, we can actually measure the amount that San Andreas moves. We can literally see the displacement just on curbsides and yards and things.
Yeah,
There's
like
areas where it just slowly, continuously creeps rather than having bursts of earthquakes. You can actually just see the slow. I mean, not you can't watch it move, but you can come back in several months or something and see a small displacement.
pull out a
Yeah,
tape measure and be like, oh, that
a few millimeters
crack has
sometimes. Yeah, or
grown
more.
or moved. That's yeah,
Hmm.
that does seem like a lot. Do okay, so the Himalayas, for
Yes,
example, is
they
the
are not
result of
volcanic.
some kind of huge tectonic event.
Yes, two continental pieces of crust colliding. Remember
Just
when I said you have to have an oceanic piece to subduct,
yeah.
to sink?
So they're
Well, in
both
the
kind of
case of the
mashing and going
Himalayas,
up. Like,
hmm yep.
are they
So
still
it's all
moving?
that material just goes up and into the earth, and so it just rises in both directions. Yes, it is still shoving itself. India is still shoving northward into Asia.
So you think does that mean that like Everest grows a little bit every year?
I believe so. Yeah.
Like just millimeters at a time, but Everest is getting taller. That's so...
Let me see, because it might be at a height now that the weathering is kind of keeping it in an equilibrium.
Right. Yeah, that's something I hadn't
How
thought about.
fast is Everest growing? Let's see here. 2.4 inches or 6.1 centimeters per year. Now, I don't know if that accounts for, if that's its total growth, in addition to weathering and erosion, or if that's just without weathering and erosion. I suspect it's the total amount. Most people don't take that into account.
That's like the rate. I don't know. I was going to say the rate of a person, but I don't know. People have growth spurts and stuff. You say like a few inches a year?
So yeah, 6.1 centimeters per year, 2.4 inches, roughly.
That again, that seems like not alarmingly fast, but faster than I ever would have thought. You know what I mean? Like,
yes,
just a whole... See, I mean, I don't know how big the continental plates are. Pretty freaking huge.
They are big and small because plates are divided into microplates and minor plates. So you have major, minor, and microplates, and things get really, really complex structurally in tectonics because it's not just the big 12 plates, right? It's a million little tiny faults all over the place that are colliding and crashing and separating and sliding past one another, and it's just all over the planet constantly. And the quietest parts, I think, of the Earth are really underneath the ocean, where next to spreading ridges, where you just kind of have those nice quiet abyssal plains. There's really not a lot going on tectonically in the abyssal plains, but yeah.
Is the Mariana Trench? I suppose like the opposite of a mountain.
It is actually. It's the deepest trench that we have. It's the deepest point in the ocean that we know of.
Yeah.
And I mean, we do know that because of satellite data now, so that's pretty easy to obtain.
We're not
now
sending
to get down there is another story.
Tiny little submarines to measure it anymore.
Exactly. So that's the deepest area, and it's caused by subduction. Anytime you get a subducting slab, you get a big trench like that. And that's why Japan has so many earthquakes and volcanic activity, is because of that subducting slab right there that's creating that trench.
Yeah, I think I was gonna go there next because when, funnily enough, again because of my fascination with nuclear physics as well, was looking at the Fukushima disaster and everything, and like the earthquake that happened there that caused the tsunami, right? Or both happening at the same time.
What happened.
So how
the earthquake caused the tsunami.
So the earthquake was, I guess, a result of some tectonic movement.
Yes.
That caused a huge trough to form in the... Well, I don't know. You could probably explain it better than me. But how did that go down?
So basically, you've got Japan. It's a continental piece of crust. You've got the subducting plate, and it tends to lock up. And then all of a sudden, you get this burst, this slip, such that the overriding plate slips vertically. And part of that overriding plate is underneath the sea. So when you get that vertical movement, it actually shoves water upward. And as that water is shoved upward, it's going to create space below where more water is going to fill in where it's being pushed up. Does that make sense?
Yeah, yeah. Because you've got that you get a huge recession of water away from the coastline.
Exactly. Yeah. You get a huge recession of water caused by that bulge of water building up in a three-dimensional bulge, basically. And then it slowly radiates out in 360 degrees as near field and far field tsunamis. The far field being things across the ocean, near field being Japan in this scenario. And then they get
the whole coastline of Japan, I guess, just kind of taking.
And those waves continue to dissipate. They basically multiple tsunami waves hit. It's just the first one is going to be the biggest.
Yeah, because there's a lot of water.
What happened with Fukushima is the reactor was flooded. No. The power went out, and then one of the reactors was flooded, reactor 4, and it ended up also going out. The backup generator, I'm sorry, not the reactor, the backup generator was flooded, and it went out. So both sets of power that they had to keep this thing cool weren't operational anymore, and reactor 4 then exploded, which I find ironic because it was also reactor 4 in Chernobyl.
The not to risk getting slammed with libel on this podcast or anything like that, but apparently we're talking a time of like at least I think a decade. The company that oversaw the maintenance of the Fukushima power plant basically neglected to update their safety equipment over sort of the
Oh,
course of like 10 years or something.
I
So
didn't know that.
yeah, so when the plant was put together, they put it together with the worst case scenario in mind when it was built. And then years following,
I do remember that. Yes, they
several
did.
several different like I think including the Japanese government, but several different bodies basically weighed in and said, "Hey, the new worst case scenario is a lot worse than you have
Yeah.
prepared for," and even predicted essentially water as high as that tsunami that year, and they didn't update any of it. So
They
that's
did
a
build a sea they built a seawall for that prediction, I believe. And they the seawall wasn't still wasn't high enough.
but the plant itself basically
Yeah.
nothing changed, and that's why things like the backup generators got flooded and stuff. So yeah,
Well,
that's a little bit of fun corporate
that's
negligence.
actually crazy. And I
Yeah,
am glad that I know that now because I'm a huge advocate for nuclear energy. Um Personally, and most geologists I know are. And I thought that was all natural disaster, which kind of paints nuclear as not great, but knowing that it's mostly user error again, kind of, well, it's
yeah,
disappointing and sad, but it's also like, okay, so we can do this. We just have to make sure we don't mess around.
right. Yeah, and it was the same, of course, going back to Chernobyl, causing a lot of
Yeah.
panic around nuclear energy. But again, it was down to negligence and poor operation and stuff.
Yep.
But
We can make sure that doesn't happen.
yeah, and again, and people say this about Fukushima as well. It's like it was pretty prepared for both of those events, just not at the same time. I think was kind of the sentiment of how like they'd set it up to be ready for an earthquake. They'd set it up to be ready for a tsunami, just not a huge earthquake and tsunami striking,
Yeah.
as a result of
The,
one
the
another at the same
problem
time.
is that the Japanese, at least the geologic people there that are studying, they know very well. So do geologists around the world know very, very well that any kind of subduction zone like that is going to cause megathrust earthquakes, occasionally causing tsunamis. And we've
Yeah,
seen evidence of tsunamis on the coast of the Pacific Northwest during the 1700s, for example, from Japan's earthquakes. So we've known and they've known that they have these giant
they're
flooding.
comorbidities sort of thing. It's like when there's an earthquake, there's going to be a lot of water that follows, and
Hmm.
they
But the
probably
other
should have
thing
been prepared
is,
for both.
well, Japan is one of the most prepared countries in the world for earthquakes.
Yeah,
California and Japan are probably two of the safest areas to live in the face of earthquakes because of the engineering feats that have been done. It's pretty amazing.
fortunately, they're also well, today's a bad example to say so, but they're prepared in the face of earthquakes because they're in the face of earthquakes pretty often.
Yes.
Whereas,
Yes,
I
exactly.
think I remember one earthquake that happened in the UK, and it was maybe 10 years ago or a little more that there was like a tiny little earthquake in the UK, and it apparently woke people up, but it was not that bad at all. I have no idea what caused it because
I don't either.
yeah, we don't have anything going on. The phrase pressure earthquake is in the back of my mind, but I don't know if that's a thing. But yeah, it was like
Compressional.
it was like the Market Raisin earthquake.
Yeah, you guys have no major
Yeah.
boundaries around you.
So in 2008, the Market Raisin earthquake. It was on the 27th of February 2008. It was a registered reading of 5.2 on the Richter scale. Yeah, it was up in the north, and it was like 1 in the morning, and I slept through it. But
Oh,
apparently, one
yeah,
person got
5.2
hurt.
isn't anything to scoff at. I don't know why they're reporting it on the Richter. I thought they had changed all of them over to moment magnitude. Richter isn't accurate for anywhere other than Berkeley.
Oh,
It's a good scale. It's very, very good. And the moment magnitude is based off the Richter scale because they're both logarithmic. It's just that the moment magnitude accounts for local tectonics, um, the area of displacement, the length of displacement, the magnitude, and maybe a couple of other variables I can't remember.
Apparently, it
Become
was
really impressive.
caused by the sudden rupture and motion along a strike-slip fault beneath
Oh,
Lincolnshire,
so this kind of motion.
which is where I lived at the
So
time, actually.
that's San Andreas kind of motion. Those are going to be shallow, dangerous faults, or yeah, shallow and dangerous earthquakes. Typically, the bigger the strike slip boundary, the typically the more dangerous. So the Anatolian Fault in Turkey is an example of that. The two
The
biggest in the
earthquakes
world I
of
can think of.
northern Europe are intraplate earthquakes, meaning they're not close to
Yes.
tectonic plate boundaries. Most intraplate earthquakes are thought to be driven by distant tectonic stresses.
Hmm.
Not of my depth here, but there you go. That's the one earthquake that I experienced while asleep.
Intraplate just means in the middle of a plate
Yeah.
without tectonic. So Australia, with if they have any kind of tectonic, or I'm sorry, earthquakes in the middle of their country, that would be considered intraplate because they don't really have any major tectonic boundaries there. I mean, new ones could potentially develop. Maybe a new spreading zone like in the East African Rift Zone. That's another way you can have volcanic activity without collision. Is just two plates are spreading apart, thinning the crust enough that you get what's called decompression melting because you're allowing for less pressure up on the mantle. So it starts to thin, or the crust above it starts to thin, and all that release of pressure allows those very, very, very hot material to start melting.
So, let's see if I remember this right from like primary school, but it's crust, mantle,
Yes.
and then is it just outer core and inner core? Is it that?
Yeah,
Yeah.
it's that simple.
And the mantle is like the biggest
Yes.
portion. It's like,
Yes.
and it's you said it's you said it's plastic, like it's not liquid,
It's plastically deforming, so like
plastically
putty.
deforming.
So you can imagine glass breaks rigidly. So
Right.
if you take a hammer to some frozen putty, let's say it's frozen in the freezer, so it's really, really cold, and you take a hammer to it, it's not going to break. It's not going to shatter. It might dent a little bit. That's kind of like what the mantle is, but hot.
So what's okay?
It's going to flow
This is such a
instead. That's what the mantle does. I know.
this is random again, but like, what's the deepest we've ever like? What's the deepest sort of man-made hole?
Kola
How deep
super
have we
deep
ever
borehole in
drilled?
Russia. I think it's like 12,000 feet deep or deeper. Kola super deep borehole. The reason they had to stop drilling is because the pressure temperature conditions were too much for the equipment. So we had to stop. They had to stop. This is in Russia. Let's see how
Right.
they got. Oh, 40,000 feet. I'm way off.
Jesus
12,000 meters.
Christ.
My bad. 12,000 meters, 40,000 feet. And this was in 1989. I want to say they tried to re-drill and it it died really quickly.
How? Okay.
Okay, the US had a similar project in 1957, Project Manhole, no, Mohole. Mohole. Oh my. Check out my mole hole.
so, so okay, and that does that penetrate the crust? Is it, are we? How thick is the crust at that point?
Oh,
Oh God.
the thinnest the crust really could be is, God, I don't know. The Basin Range is really thin at 40 kilometers.
That's really thin.
That's super thin. I wonder how
But
thin the East African. I don't
but
know what the thinnest.
40,000 meters, I guess.
The oceanic crust is a lot thinner. It's like, I don't know, down to as thin as about 10 kilometers thick in some cases, but then getting through all of the pressure of the oceanic water just to drill through the oceanic crust would be a nightmare.
And what is the mantle made up of? I mean, I don't imagine there's any value
Peridotite.
in getting there.
Want to see it?
Sure.
I have a piece of the mantle.
Oh shit. Time to see another rock.
So this is some basalt. So sometimes when volcanoes erupt, if they are going through thin enough crust or they're really of uh, I'm going to get way too detailed. Anyway, so sometimes when volcanoes erupt, they pull up pieces of the mantle, and those pieces are the green chunks here.
Right. It looks
So those are pieces of the mantle. They're mostly olivine. It's
it looks
called
edible.
peridotite.
So
It is, yeah, tons of olivine. It might be dunite. Mostly olivine.
A very
A lot of
green,
olivine.
green hue.
Pyroxenes. Yes, that's the olivine. Olivine is peridotite, or is, I'm sorry, peridot, the gem peridot, if you're familiar.
Yeah, okay, yeah.
People often. It's not a very stable gem though at superficial conditions because it likes hot conditions. It's usually solid in the mantle. Of course, it is extremely hot, but then it comes up and
So the mantle is
just
kind of
forms these little blibs.
like
This is
chocolate
very
chip cookie
dense.
dough.
No, 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 because this is the lava. The black stuff is the lava, or the
Uh-huh.
gray stuff. And it's basically flowing up through the mantle, right? And it's tearing these chunks of the mantle with it and bringing them up solid. They're brought up solid. Otherwise, they wouldn't look like this. They would have melted and mixed in with the magma, becoming part of this. But
So
instead, they were solidly ripped up and brought to the surface.
it's a lot of rocks down there, man. It's rocks all the way
There
down.
are. It's just that only part, you have to understand that most of the mantle isn't molten. Only of little tiny pieces of the mantle are molten or actually magma. And even in the magma chambers that do exist, they're only partially molten. Like solid minerals float around in magma chambers all the time. And there isn't a purely molten magma chamber that I know of. It's more like a slushy kind of a mix. So when they erupt, you often have little crystals and minerals in them. And not every single time. You can get a beautiful flow without huge crystals. But even in this, like if I rotate this, I see tiny sparkles. That to me indicates there's minerals in there.
There's something else in there that's not just
Yeah, it's not
what
just
meets the
a
eye.
homogeneous melt. It never is. It's a very heterogeneous, constantly changing mess. Magma
A
and
beautiful
magma
mess.
studies, it is a beautiful mess, but the study of magma and lava is a huge branch of geology in and of itself. It's
Is there
so chemically
is there a difference
complex.
between the two? Between magma and
Of
lava?
what? Yes, lava is on the surface of the earth, magma is below the surface. That's it. It's kind of
How
dumb.
um in okay, we've seen videos, especially from like Hawaii, when something erupts and there's just this slow crawling like mass of what is lava at that point. Now I know, and it's like coming across a road or something. How much heat radiates from that? Because you see people get pretty close. Like, I mean, have you
Never
been?
been
Have you
to
been
a.
that close to lava? Have you been?
No, I
No.
wish.
Damn.
I used to have nightmares of it as a kid, but now I want to really bad. I've
Yeah,
never
that's
ever
an
been to a
interesting.
lava lake. I've never seen a lava flow, and I am so ready for it. I am
Have you
ready
been to
for it.
like not inactive, dormant volcano? I guess
Mhm.
like
Oh yeah. The first one I think I remember going to is Crater Lake as a little girl. Crater Lake is a huge, huge volcano. In fact, um, that crater is was caused by a huge collapse from all the magma that spewed out of that volcano um, thousands of years ago, and basically emptied the chamber such that the overlying rock couldn't stay up, so it all collapsed inside. And the island that's in the middle of Crater Lake is a resurgent dome from magma refilling the chamber.
from below, from deep beneath.
Hmm.
So
Inside the volcano, it's pushing all the rock up again.
it blasted its freaking load,
Top off. Yeah,
collapsed
it
because it didn't
did.
have enough
Yeah.
left, and then it's still just, but it's still coming up, but it's just too slow to
Oh
kind of
yeah, it's
maintain
active.
that. That's wild.
Oh no, it's still active. I mean, the resurgent dome on Mount St. Helens was fucking crazy. That thing was moving almost meters a day for a while. A couple
Of
years
just
ago, they did time lapses of all the rock spire just being pushed up from within. It was crazy.
that, like,
Completely solid rock.
at what, how does this, like, how does the rock, so like magma that's erupted from volcanoes and making like new islands and things like that, how does it get replenished from where it came from? Like, what is stopping it from running out? You know what I mean? Like, what's stopping it all from essentially being
Heat,
pushed out onto the surface and emptying whatever is holding it all in there?
heat. Earth has lots and lots of heat through
So
radioactive decay.
is there not convection currents, but like, is there something that's kind of
Yes. It's
melting other
convection.
material and bringing it back in as material is being
Yes.
erupted?
So there's definitely a cycle, but it's not these nice, beautiful circular convection currents like you see. It's a very heterogeneous clusterfuck of a mess. Um, it's just a nightmare of random subduction zones. So you've got old crust sinking that's cold, bringing down cold material, but it's also causing melt to form. So it's bringing up warm material in response. Um, because the two major forms of melt are flux melting and decompression melting. So you get these two based on tectonics, but you're also getting subduction in some of those cases, causing more cold material again to recycle back in. So you have a driving force called slab pull and slab push, which are ultimately the controls on all of this. Um, Basically, the slab, once it's being pushed out by a spreading ridge, for example, it then kind of sinks into the earth and acts like an anchor and starts to pull itself down. So these things kind of drive themselves because of ultimately the heat and the recycling of that heat. If there
Heat
was no heat in the
and
planet, then
everything
it would
moving
all lock
around.
up and die. Hmm.
So
Is this too much? Am I being too
no,
much?
I'm
I don't know if
I'm
I'm.
I'm I'm trying. I'm doing my best to take it all in
Okay, good. Because I know there's
because
a lot. Geology is a lot.
the hardest thing. So as you explain stuff, I'm trying to like eh, picture it in my mind, right? Of
No,
like
visuals are so important for this science.
all of these things, like all of it,
Yeah.
because you know there's so many moving parts all the time, which is a little
Yes.
hard to even like think about. There's the whole sort of you get existential and you think about how tiny we are in the universe and all of that. But even on our own planet, like there's so much just moving constantly.
Yes.
And like, oh, this is just a funny
Believe
little
me, the existential dread is real in geology for me.
a
I
little
realize
a little
how
fun
every single day.
exercise. A little fun exercise of like if we got everyone on the world into the same place to jump, we would move the Earth in its orbit like a centimeter or less. Like
Yeah.
even compared to the planet, like let alone in the universe, we're very very small. I mean,
Hmm. I find it to be kind of beautiful though.
yeah, I mean, right? Because we all
We're
despite
unique and
our insignificance, we all have our own place. Isn't that amazing?
exactly. That's
Um,
exactly what I feel. It's very humbling and very peaceful.
yeah,
Even like it used to cause me tons and tons of dread, but now I just feel that okay, I'm part of this big cycle that is the Earth, and eventually all my atoms will go back into this cycle.
that's the
So I
best
won't
part.
really be dead. I'll just be part of the Earth, and that's okay. Like
The
my
little
consciousness probably won't be there, but
who knows, upload it to the
I don't know.
cloud in 20 years or
Yeah,
whatever, and
exactly.
be
Then I
around
can watch all my
forever.
atoms dissipate into the Earth, I suppose.
Well, yeah, I kind of want to be
I want to be digital
composted.
now. I want to see how the I want to see how humanity fossilizes.
I'm sure. I want to know. I want to know beyond that, right? It would be cool to
Yes.
see how humanity fossilizes, but it's really interesting now, especially with how everything is. Thinking whatever the fuck finds us, if anything, in a hundred
Oh, I
thousand years, I don't even
yeah.
know. Probably nothing. But if something were to find us, because even now there's I can't remember the name of the practice, but that the practice of essentially creating um, signs and like icons for biohazardous waste and like
Yes.
nuclear waste and things like that. Because when we bury, a shitload of nuclear waste under a fuckload of concrete, and we put a sign up, we have to kind of hope that because language changes so much and like
Uh-huh.
we don't understand things from 1,000 years ago. Are they going to know in 1,000 years what that sign means when they find it, or are they going to think are they going to start digging and then die because because there's a bunch of hazardous waste down there? Stuff like that is very interesting to me to think like
I think so
what's going to
too.
be understood from what we leave behind in 1,000 years, especially with the
So
like the
much.
rate of change and everything.
I can't imagine it's going to be all correct. It'd be so funny to be like, and the humans did these things. I
Yeah,
don't know.
yeah. They called themselves mankind.
Mankind.
Yeah, like that whole process of like
They'll just see the
preparing for
biohazard sign and be
the
like, oh,
future
how what a pretty symbol. It might mean
must be the
God.
playground.
Yeah.
We must
Yeah.
dig. Um,
Jesus.
that actually something that was in the back of my mind earlier that brings me back to it. How do we mine
How do we
nuclear
mine?
fuel?
Oh, through various rocks that contain either uranium or thorium.
But is it safe? Like, how safe is it? Like,
Mm,
how do you do that on a safe in a, I guess in a safe way?
that's a good question. I don't
Are
know
there
what
dudes down there in
safety
hazmat
practices.
suits and excavators
Well,
just pulling?
usually monzonite and uranium, I thought weren't too deep. I thought they might actually drill for those. I don't know. I don't know what the safety protocols are for uranium and thorium mining. And I
Guess that
want
order
to
would have
know
been
so
100 years
badly
ago,
right
but
now. Yeah, there probably weren't any until about 15 years ago
yeah,
when
right.
the internet became a thing and everybody started sharing all this information and governments are like, oh shit, guys, shit, they know.
I mean, it was like, oh man. So to go back to one more time, I watch a YouTuber called Kyle Hill. He's the guy
Mhm.
that I learned literally everything about nuclear disasters and nuclear physics and stuff. So he has a series talking. It's called Half-Life Histories, and he talks about all this stuff. And man, the things that they were doing with with like nuclear physics in general and like the Manhattan Project and stuff was just awful, like so bad. Someone in chat
There's a
said
lot of
uranium's
bad
not that
stories.
dangerous, so there you go.
Yeah,
Um,
I don't think uranium 238 is all that dangerous just
I
as
guess
a
it's when
raw
you
element, but
when mining it's not that bad. It's purifying it, processing it, and turning it into fuel. Um,
it used to be a byproduct of mining thorium, but it's actually being sought out now as there's several projects working on thorium salt reactors.
interesting.
Hmm. It's actually way more common than uranium. Thorium is.
Oh, speaking of mining safety, did you see the meme of the guys having the asbestos shoveling competition?
Oh no! Did they wear masks?
No, this was like 200 years ago or something. It's like a black and white photo. It's just a bunch of dudes outside of mine. Yeah, right. Oh man.
Mesothelioma.
Oh yeah,
Good God.
yeah. I didn't know we
I mean,
mined
there's.
asbestos. I didn't know that's
I have a video of asbestos on my Instagram, but I only got it out once, and I turned off my fan. I used gloves and a mask, and I'm like, "This is a chrysotile. This is a mineral. It looks like danger cotton candy."
really. Wait, like
It's
fibrous?
yeah, dude. I
Like
have here. Let me show you really quick. Let me see if I can find it.
oh, I gotta see this.
It's crazy. It's definitely crazy looking. Um, I need to start doing more mineral videos now that I have a phone camera
Oh
again.
yeah, it looks kind of like fur in a weird way. Like it's all these fibers
Yes,
all in the same. So yeah, all of these like aligned
I think
fibers.
this one should be it. Can I post a link? Oops,
Oh
no.
god.
It's okay. It's not a big deal. I'll
I'll
send it to
see.
you.
I
I
see
think
it.
it's.
I see it.
I think that's the one.
Oh yeah. It's like matted hair.
Mm-hmm. It's really weird. It's
What the
very
heck did we
fibrous.
use? Why was it in everything? What
It's a good heat deterrent, or what is it? Fuck, what is it?
insulator?
A fire retardant,
Right,
right?
because it's in
That's
like fireproof gloves and stuff
yeah.
like that.
That's what I think it was for. Yeah, it's an insulator. Thank you. That's the word. I don't know what the hell's wrong with my brain. I have COVID brain.
COVID brain. Great insulator and cheap. Because nowadays we use fiberglass insulation, which is I guess I don't know why fiberglass insulation, but it's like the man-made equivalent, right? It's these long fibers of, but we make it
Hmm.
ourselves, man-made fiberglass instead of
Yeah,
mining asbestos. That's very interesting. To see something like that naturally occurring, like as a mineral,
yeah.
right?
I
Like how,
know. Isn't it crazy?
because it looks, yeah, it looks organic. It looks biological, I should say. It looks living, uh, like I don't know, all these little strands of hair, kind of or like a fungus.
Yeah,
Um,
it's very strange.
so yeah, I
And it's
mean,
scary to play with because you can't even see all the fibers. There's like they're like spider webs.
yeah, I mean, I feel like fiberglass behaves in a similar way. You can get
Yeah.
fiberglass in your skin, and it'll like be really, really irritant. So apparently, the Romans would make tablecloths out of it. That's asbestos. And when they were dirty, they would just stick it in a fire as a party trick. Because it's like, of course it can't burn. It's rocks, guys.
Jesus Christ, the Romans are just like Americans. Let's burn this shit.
Yeah, that's just I don't know. I can't imagine coming across something like that in its natural state and just being like, oh, it's fibers of mineral. I don't know.
Yeah. Yeah. Literal mineral fibers. And that's why fibrous is actually a term to describe mineral structures in some cases.
Oh,
Because they are
okay.
naturally occurring.
So there's when you're looking at the qualities of a mineral, there's like several qualities in particular, right? That you're grading.
Yeah, physical properties.
Yeah.
Yeah,
What
that's
are
one
those
way.
properties, and I guess we'll start off. What are each of those qualities or properties in a mineral that you're looking at?
There's a lot.
Oh, there's a lot.
So the definition of a mineral is that it's naturally occurring. It's solid, naturally occurring solid. Oh my gosh, chemically defined or chemical definition. Crystal, lattice, so it has a structure.
Okay.
Crystal structure. Oh my gosh, what's the fifth one? Naturally occurring, inorganic. So these are the five things that make up a mineral. That is the definition of a mineral. It has to be naturally occurring. So, diamonds that are made in a lab can't technically be considered a mineral. They would just be said to be man-made, right? It's not that big a deal. And technically the ones in the man-made labs, like if you're looking for pure diamonds and things, just get a man-made one. They're going to
Diamonds are
be
a
way more
scam,
pure
right?
than,
Let's
yeah,
be
they
real.
are. But those are the five definitions. And then you've got a lot of properties that we use to identify minerals like
Yeah.
cleavage, hardness, luster, sometimes color, tenacity.
Is a luster how shiny something is? Is that what luster is?
Mm-hmm. Yeah, that's how
So it has like a
how much light reflects off of the mineral.
reflectivity index or something.
Yeah. Yes. And that's
It's right off the top of my head, guys. I'm a genius.
it's how we basically classify minerals based on their shininess. And they each have a very specific index of refraction. So you can determine via chemistry and via microscopy which is which, just in some cases looking at the luster. But that's really pretty difficult. You use the luster as a kind of a baseline. Is it metallic or not, essentially? Right. And then you go from there to determine its hardness using a variety of tools. And hardness is just the ease to which you can scratch into a mineral. And we use the most hardness scale for that.
Right.
We can occasionally use color. You want to definitely write it down. We also use streak, which is the color of the mineral when it's powdered. And you do this by taking a ceramic or like a little white or black ceramic tile plate, and you lay it on the counter, and then you kind of just scrape the mineral back and forth on it, yeah. And you put it on you just drag some of the mineral across it, trying to crumble pieces of it, and it will often be a different color. And if it is a different color, then it's probably a metallic.
What has the greatest difference in color between naturally occurring and what was it called? The streak?
The streak.
The streak.
I know, streak, hardness, cleavage, they're all kind of funny, but the hematite has a really, really crazy streak because it's always going to be red-brown. But the mineral itself could look like shiny silver. It could look kind of like a dark gray.
Now, chat, if your streaks are red-brown, see a doctor, first of all.
Yeah, and you might have hematite in your streaks.
Yeah. So...
Don't want that. I mean, it's just oxygen and iron.
Yeah, rust, thermite, in some cases, something like that.
I mean, yeah, that's why hematite looks so weird sometimes. Sometimes it looks just like rust, like a little rock of bright red rust. Or it can look really metallic and shiny, but either way, it's going to have a red-brown streak.
It's very strange. Because I'm thinking, like, if you take a piece of it and draw with it like chalk. Like that's what I'm thinking in my brain. Is like I've got the
Yeah.
shiny metallic rock, and then you just like chalk, but it's a red
You want me to do
streak.
it? You want me to show
If
you?
you have some good examples, yeah.
Yeah, let me grab some.
Hematite's botryoidal texture is really weird. I'm gonna have to look up the word botryoidal right now. Botryoidal, a shape reminiscent of a cluster of grapes, chiefly of minerals. Maybe the underside of my car is made of made of hematite. I've been chugging water throughout this podcast because it's so warm. I close my window and I turn my fan off because I want the audio to be crisp, of course. Only the best here. And I've got through a freaking pitcher of water. Man, I'm dying. I didn't learn this in Pokemon. What is this? So it's funny when we got on to talking about sapphires and rubies, my brain immediately went to Pokemon. Who knew that sapphires were made of? I already forgot. Sapphires are made of titanium and something else.
Sorry to disappoint, but I can't find my hematite. I think it's in my garage somewhere.
Oh.
I have hematite that's red already.
Hematite that's red already?
Yeah, so it's like you can see some of the gray in there. So both of those colors are natural.
Like it's all the same thing.
Mm-hmm.
But it's just red and gray.
If I take a streak plate like this, you would normally just want to put it down on your surface because it can break. And you just kind of...
Oh, yeah. A red-brown streak. Look at that.
Yep.
From a gray, partially gray rock. But it would always look like that. Like the streak is always going to look like that.
The streak for hematite is always going to look.
That's interesting.
Yep. Yeah, this is a classroom mineral collection you can get off of geology.com for like
just a whole
$30.
Tray of rocks.
Yeah, lots of stuff like bauxite and sulfur.
What's the really bright yellow one? What is that?
Sulfur.
Oh, okay. I didn't know it looked like that.
Mm-hmm.
Does the rock smell in that form? Does it smell?
Yeah, a little bit. It's
don't taste it.
You need to powder it to let oxygen bond to the sulfur. Ugh,
it kind of looks like egg yolk though. Like that's interesting.
It does.
No wonder it smells like eggs.
It does look like egg yolk.
Yeah.
Got little topazes.
Ooh.
Tons of stuff. Quartz that's pink, even though it's still just... Oh, here's some halite. Perfect cubes. Perfect 90-degree angles.
Oh, yeah. That's to do with the crystal lattice structure or something. Yep. Yeah.
Sodium and chlorine fit together beautifully in these cube structures.
So it's the same composition as salt? Like...
Yeah.
Just a different...
I could
different arrangement?
brush it up. Oh, it's so salty. That's a lot of salt.
She licked the rock for anyone listening.
Ugh.
Which one of them tastes best? We were trying to get to the bottom of this earlier.
I don't want to taste all these rocks.
I mean, how many of them are safe? Food safe?
I don't know. I might have put acid on some of these too. So
right.
I might have just eaten hydrochloric acid, but that's just what's in our stomach.
Oh, it'll be, it's old. I'm sure it's fine. Someone asked, how do you stop them just turning to powder? But
they don't just oxidize. It just depends on the minerals. Some minerals do oxidize in ambient air, but most of mine don't. How many of these rocks are food grade? Don't eat your rocks. If you feel like eating rocks, you probably have a disorder called pica, where your body is craving minerals and things that you're deficient in.
My fun fact lately has been the guy who ate a plane. Do you know about the guy who ate a plane?
A plane?
Yeah, he ate like a whole plane.
What are you talking about?
He ate a plane.
How do you eat a whole plane?
Bit by bit.
Like a tiny airplane? It
was a small plane,
or a big, like Boeing?
No, it was like a... Oh, I don't want to say a Cessna because I actually don't know anything about planes. But he had pica, and he was renowned for eating weird things.
Oh, here's Boeing. He's in jet.
Yeah. He was renowned for eating weird things, and yeah, he threw over the course of like I want to say at least like a couple years, he was eating this plane.
Jesus.
Just like one bolt at a time. I don't know. I feel like bits of metal's fine, but the tires and like the windshield, he have a good dipping sauce? I
Did
hope
he
so.
die? Is he
Uh,
okay?
is he okay? I'm gonna have to look it up. The guy who ate a plane. So
I'm gonna learn things today.
Michael Lotito,
Why
famous
did
for
he do
deliberately
this?
consuming indigestible objects. He was called Monsieur Mange Tout, Mr. Eat All. Um, he holds the record for the strangest diet in the Guinness Book of World Records. He died of natural causes. So,
Sure.
but
What
he was
natural?
57, so like he didn't live the longest. But yeah, it was a Cessna 150 light aircraft. Oh my god. Okay, no, it gets weirder. It gets
I mean,
weirder.
I
What?
know that there are disorders where people eat random objects,
Yeah,
but
yeah. That's
that's what it was
that's
based on. It wasn't.
He had an eating disorder known as pica, which is a psychological disorder characterized by an appetite for substances that are largely non-nutritive.
Oh, he
He
did have
also
pica.
had a thick lining in his stomach and intestines, which allowed his consumption of sharp metal without suffering injury, and digestive juices that were unusually powerful. So, this guy was built to eat planes.
What?
He was built to eat planes. His digestive juices were actually too powerful for him to eat soft foods. Bananas and hard-boiled eggs made him sick, but he was built to eat planes. He ate 18 bicycles, 15 shopping carts, 7 TV sets, 6 chandeliers.
Did he not eat anything normal?
He must have, right? Like, to live. But throughout the course of his life, he ate a lot of things. He ate his Guinness Award plaque, which is just beautiful. That's poetry.
Plain on every plate, the dream.
Um,
What the fuck,
so
man?
there you go.
I'm gonna go back to bed today after this.
Nobody let this person into a Target. Well, he ate 15 shopping carts, so I think
Oh
the
no!
exterior of the Target is the big issue. Catch him in the parking lot with.
He's just eating one of the cement fucking balls in the front of the Target. Jesus Christ. Ugh.
So yeah, that's the life of Michael Lotito. What's the most? Okay, no, this is. This leads me to a genuine question. What's the point of eating gold? What's the deal with that? What's the gold leaf? What's the obsession? Is there any reason?
There isn't.
Have you
There's
seen?
no point. You just shit it out. It's a
Well, because
decorative thing that makes things more expensive so people will buy it.
Have you eaten it?
No.
I want to know what
I
it
mean, I've
tastes
had
like.
Goldschlager before, which is a liqueur that, like back in the day when I used to drink, I had this. It's like a cinnamon liqueur, but they put these little
It
gold
has
leaves,
gold leaf in
flakes
it.
in
Yeah.
it. I just like the flavor of it. It's not all that expensive. I
Yeah,
don't
but you don't
understand
taste the
why there's
gold,
gold. No,
obviously.
it's just in there for fanciness, and you don't digest it. I think you just shit it out.
Because we have a lot of minerals.
It's I don't think soluble in our stomach, Koiba.
Right. Well, I think I don't know about poisonous, but it's not a heavy metal, right?
Like for
So
example, cinnabar. I recently learned a mercury sulfide. Uh, it doesn't. It's not soluble.
another
If you lick it
Pokemon
in
thing, by
things,
the
even
way.
though it's a mercury sulfide. And so my buddy was like, "Oh, I'll totally lick some cinnabar on your stream," and I'm like, "Oh my god." But I mean, I personally wouldn't lick the mercury sulfide still out of fear, but it's not soluble. I mean, if you ate it, that might be a different story. So don't eat it because stomach acid could dissolve some minerals, all the carbonates, for example.
Yeah,
And that
mercury
would,
messes
let's
you
say you
up
ate
big
some
time.
malachite, copper poisoning. Yeah, mercury can really fuck you up.
Yeah. How this actually came to me a few days ago, and I can't even remember where from. But copper, in its like, oh, I'm trying to remember exactly where I saw this. It was something to do with copper bowls. It was a video. It was a video by a chef talking about cooking with copper and how cooking with copper can potentially be dangerous, but if you don't cook acidic foods, it's fine. So copper is used very early, like early humans, because you
Hmm.
find in its natural state can be found basically just as lumps of copper, right?
You can, yeah.
Whereas something like iron is more commonly found in an ore that you have to extract it
Yes.
from. So
It,
how does how does that happen? Like, why do you find just lumps
that's
of copper versus iron being part
It
of
depends
an ore
on
more of the time?
it depends on how its ability to oxidize, and it depends on the environment in which it forms. Iron is, well, ever since oxygen came about and filled our atmosphere about 2.5 billion years ago, we had what's called the Great Oxygenation Event, and a lot of that iron became oxidized and turned into hematite or magnetite, so grays and reds. So we had bands of grays and reds and grays and reds and grays and reds all of a sudden all over the earth
Right.
that were about 2.5 billion years old. And so we know iron oxidizes extremely well. However, if iron is in an environment where there's not oxygen, it'll bond preferentially to sulfur next if sulfur is available. So then you'll get things like pyrite, for example. And pyrite forms, for example, in a lot of oil reservoirs because it's anoxic. There isn't oxygen down there. So it tends to bond with the sulfur produced by the organic materials that decay. It's
Whereas
pretty cool.
copper,
As for copper, I don't know why
not as good at making friends.
I guess it doesn't oxidize as easily is my guess. That's a good question for my friends over at Mindat.
Hmm.
Yes, gold does tend to form on its own. It has a really low melting temperature, if I remember correctly, so it forms last in a melt typically.
That could be the same with copper then.
It could be. It could be.
Right.
'Cause silver also forms itself as a as an ore too, and it can be silver in and of itself, but it often does bond with other things. Some ores bond with things easily and some don't. I guess it's likely to do with the conditions on which it forms, and it probably has to do with something chemically about that element that I don't know about.
What is it in particular? Well, I guess metals especially that makes them better conductors than
Oh, metallic bonds.
right. But what
So
does that
quartz,
mean?
for example, has covalent and I think just covalent bonds. So it's a pretty hard mineral, and it's not very good at conducting things, although it does have piezoelectricity, which I can explain in a moment. It's pretty cool.
Okay.
Um, it doesn't conduct very well. It's better. Most of these rocks are very good as insulators, but when you get metallic bonds involved, the electrons aren't really stationary. They're floating around all about all of the atoms throughout the structure constantly, such that well, electricity can flow through those things, and they're excellent conductors because those electrons are just swimming around.
Right.
They can just be exchanged freely, exactly like what Albel said. So metallics tend to be great superconductors, whereas these guys, they don't have loose electrons floating around. They're stationary to the element or the atom on which they're bound to, or the two elements if they're exchanging and sharing electrons. But for the most part, they're not great as conductors because of
That works
the
with
types of
okay.
bonds.
Electricity moves through the free electrons that are moving around the compound. Electricity can flow through. What
Hmm.
about heat? Why does it work with heat?
Because heat, there's already potential energy in there, and when you heat it up, it generates more. It generates energy, so that heat turns into kinetic energy potentially, and can allow electricity to be produced. Heat and pressure would be the two things that would theoretically make energy, and you could do the same with a piezoelectric piece of quartz because it's kind of strange, but quartz, for example, rubies, sapphires, they're used in watches because they have a specific speed at which they oscillate if you put them under pressure. So when you put them under pressure, and pyroelectric is a thing too, or temperature in the case of pyroelectric. But this guy's piezoelectric. So piezoelectric means pressure,
Right.
pyroelectric means heat. So the piezoelectric stuff, you put pressure on them in a specific orientation on that crystal, it'll vibrate naturally. It'll start to vibrate naturally, and it will then produce oscillations at a very specific frequency, which people can use in a variety of pieces of technology, even phones. Um,
So quartz under pressure oscillates or vibrates.
yes, it can. If it's on the right axis, yes.
That makes
A
you wonder
lot of
how people
minerals do
figured that
this.
out. You know what I mean?
Oh, that's a great question, and
Yeah.
there's probably papers in history on that.
Yeah.
Um,
Probably. Of
because
like
these materials are used throughout material science because of their properties. They're
Yeah.
weird little properties on the chemical scale that I don't even know every one of them. I mean, there's 5,700 plus minerals on this planet, and I only know, so much about so many of them. And of course, I'm always learning more, but there's a lot more piezoelectric and pyroelectric minerals out there than people realize. And of course, there's tons of metallics that allow for energy transfer.
So, I mean, I don't know. Like out of the it's 5,000, say 5,700, more than 5,700.
Yeah, the
Do you
International
think there's more we
Mineralogical
haven't found?
Association. Yeah, they identify 40 to 50 every year.
Oh my god. Okay,
Yeah,
fair enough.
these are becoming. Well, this mineral only exists in this one country in this location, and
Yeah.
now we found a second location. And
I
so
think there's a similar thing with elements on the periodic table where it's like I remember as a kid there's like that little section at the bottom of the periodic table that's like a bunch of random like I don't know eums and like Einsteinium is one of them and I was like what the heck is
the
this and it's
man-made
like
ones.
oh you only find that in the aftermath of the explosion of a nuclear bomb for like 5 seconds. It's like oh, okay cool like that's
Yep.
awesome.
That's
Uh,
why any of the we only account for naturally occurring elements. So I just ignore
yeah.
all the rest and pretend they don't exist.
So,
Hey, I'm
wait, are
kidding.
there some? Hold on, are there some funky man-made minerals outside of recreating
Yeah.
diamonds and stuff? Is there anything like
There's some
man-made,
really cool
completely original?
materials. I don't know about
Well, yeah, there wouldn't be
minerals so
minerals
much.
definitively, I guess.
Like what is it called? Alanon? Oh, trinitite is actually one, yeah, because of nuclear bombs. So basically if you have an explosion from a nuke and it hits the ground, you're gonna basically completely liquefy and then resolidify the ground beneath that thing pretty instantaneously, such that you end up with a mineral called trinitite that's
Oh,
man-made. Um, you get a similar thing with meteorite impacts, but it's not trinitite. That would be like moldavite and tektites. Those are tektites. Those aren't man-made.
what's the deal with space rocks? What are space rocks made of? What's the moon made of? While we're
The
at it.
moon is mostly made of plagioclase and feldspar, so the same stuff that our most of our planet is largely made of superficially. So there really isn't a lot of any. It's pretty similar to the Earth, which is why it does correlate with the theory that the moon basically came from the planet based on a collision um, billions and billions of years ago,
Just kind of
hundreds of billions of years
got
ago.
knocked away as the Earth
So
was getting
basically,
its
there was
shit
a
together.
yeah, there was a collisional event that tore apart parts of Earth, and parts of Earth started rotating around the protoplanet that was Earth, and then Earth finally came together, and all those little pieces coalesced into what we think is the moon,
Oh,
and that's kind of how that formed. That was
and it's
about four
full of
billion years
ores,
ago, I want to say.
apparently.
Yeah, and
One last thing about space rocks.
yeah,
Because you said about meteorite impacts. Are
yes,
meteorites all made of different stuff? Like
yes.
how much we looked into meteorites? Probably a lot.
There
Or
are classifications of meteorites, and this does go out of my area of expertise quite a
okay,
bit. But from what I remember, there are metallic meteorites, there are stony meteorites. So that means more like just rock, the
yeah,
basic building rocks, right? Nothing metallic. And then there's chondritic meteorites where you get little pieces of other minerals within the meteorite itself. So you can get pellicite as a chondritic meteorite, for example. And the chondrites would be the little green olivines, and I guess the matrix, for lack of a better term, would be the metallic stuff surrounding them. So anything with little pieces of other stuff would be chondritic. And then the little pieces would be chondrites.
rocky
Yeah, rocky,
things,
stony,
stony
and
things, and
piecey
piecey things.
things.
The
Hmm.
three types of space rock that you got to look out for, in case
Hmm.
one of us, one of them collides with us someday and we all die.
And most of the meteorites that do hit Earth are very small, pea-sized, pebble-sized,
At least by the
gravel-sized.
time they hit the
They're
ground, anyway.
yes, exactly.
Yeah.
They're not very many giant meteorites, and if there were, we'd have a lot of hard times ahead of us.
Yeah, there's like a I want to say somewhere in South America there's a huge bowl that could be the remnants of a meteorite strike. I think South America that I think people
Chicxulub?
they theorize was
Okay.
potentially the crater left by the meteorite that it caused the dinosaurs to go extinct. But
Oh, that's Chicxulub.
Right.
That's the third largest meteor impact crater on Earth, and it does exist.
Yeah.
It might have been the final straw that killed the dinos. The dinos were already on their way out. It didn't see the
Could have brought
dinosaur
alien
extinction event.
bacteria with it too that diseased all the dinosaurs. You never know.
They were already dying, is the thing, and they were probably going to go extinct. A lot of those species were going extinct regardless. There is a lot of debate on the dinosaur extinction that
Yeah, of
happened about
course.
66 million years ago, and there's some theories on it. I I can't say which one is better than the other, but
I mean,
it's
at
definitely
this point,
definitely a big.
just pick whichever you find the most fun, right? Because I mean, it was so
Well,
long
I
ago.
kind
How
of
are
go
we
with the
ever
one
really gonna know? You know?
because of evidence, if we get more geologic evidence. But it does suggest, so far, it suggests that they were basically already on their way out, and that that impact crater kind of finalized their story.
Right. Is that?
Unfortunately,
I guess that's like the broadly accepted. It was
hmm
probably they were
it's the
going, and
most
then a big
widely
rock hit.
accepted theory as of
Right.
right now. Yeah.
Um.
Oh, and the Deacon traps is another theory too, but that's a basically a shit ton of volcanic activity to the extent that it was actually able to affect the climate and cause a global cooling event. Because people don't understand that more volcanism actually might cause cooling, not the other way around.
oh, people theorize. I'm sure you know. Like, if or when Yellowstone erupts, there would be so much ash and whatever in the
Hmm.
atmosphere that it would reduce the amount of
It would.
sunlight or that reaches the earth, and that's what causes like the global cooling event, I guess.
Yep.
I remember when, and I'm not even going to attempt to pronounce the name. I'm usually pretty good at that kind of thing, but the Icelandic volcano erupted a long time ago, and it.
Fagradalsfjall, the most recent eruption.
I have no idea. I'll be honest. I just remember that
There's
there were
so
like
many.
flights grounded in the UK. It was like Ajaf
Oh,
Yaliokol
it
or
was
something.
Eyjafjall. Yeah,
That's the
Eyjafjallajökull,
one.
I think is.
A lot of
And
J's, a lot of L's.
yes, it starts with an E. Eyjafjallajökull, I believe, is how it's kind of
Some
pronounced. And
something
then
like
there's
that.
Grimsvot, um, which I think had actually a bigger explosion, but didn't disrupt the airports. And it was pretty much, I think one was like 2010 and one was 2014, I think. But they're both pretty big subglacial volcanoes that aren't to be scoffed at for sure.
Yeah.
Iceland's got a lot of volcanic activity because they're not only on a hot spot, they're also on a spreading ridge. So there is a ton of volcanic activity. And I want to move there. I
I
want
think
to
it's
move there
a
and
beautiful place. It looks a little bit moon landscape-ish in parts, probably
I've never
because of all of
been.
the like volcanic
I'm gonna end up
remnants.
in Scandinavia someday. I want to.
Honestly, I'm hoping to as well because I want to go to Finland.
Yes.
I'd love to live in Finland. Finland looks great, but I don't know if I would want to be that close to Iceland, close to volcanoes. I don't think I could
Oh,
do
I'm
that.
good with it.
I would have to go at least
I'm good.
once because they have all the natural hot springs. That's like
Yes.
water is like piped across the country, and everything is just this beautiful spring water. That
Geothermal energy.
yeah, I mean, it's like the country's like heated by geothermal energy and all this stuff. It's amazing.
It is
But there
amazing,
are
but it's
also
hard to
volcanoes
immigrate
there.
there.
It's a little spooky.
I want to do it. I will go to every volcano and I will film all of them and stream all of the volcanoes in
Don't get
Iceland.
close enough that you I don't know die. I
Oh,
guess.
I'm not one of those idiots. Don't worry. I might actually be one of those idiots because I'm that into volcanoes.
Yeah, that's. I think mostly what I'm worried about is just a little bit too much enthusiasm and
Oh,
silly.
lava
Well,
death.
right. How how scary is Yellowstone? How should we be
Hmm.
worried? No,
No. Everybody's always so worried about Yellowstone and it's
because
not
it's
showing
really
any activity.
big.
It is huge. Yes, it's huge and it is scary, but it's not the only super volcano on our planet.
How
We have
long
another
will we
one in
know in
California.
advance?
A couple months, maybe,
Okay, that's fine.
if
I can go for a
at
couple months,
at best, maybe a month or two. I mean, that's about what Mount St. Helens gave us.
a month or
It just
two.
depends.
Borderline extinction event.
It
All
just depends
good.
because you can have an eruption without any signals or signs, but typically most of the time volcanoes are going to give you information in excess gas influxes or outfluxes rather, and excess earthquake swarms and excess ground deformation and things are just changing, and the signals of the earthquakes are changing, and you could tell magma's moving because of all these things, such that, oh shit, we should probably warn people and evacuate. And then they do that usually upon any kind of signs of reawakening. So usually people are able to be kept safe. But the thing is again, this isn't, it's not 1000% perfect, right? You can
Right.
have an eruption that just happens. It's
Oh,
unlikely,
well,
but
okay.
it can happen.
I don't like that. I don't like hearing that very much at all.
It's unlikely. It's unlikely, but it can happen. It's very unlikely. Me as a geologist, I'm not worried that we wouldn't have some kind of a sign. I'm not worried about it. I'm pretty sure that we would have some kind of a signal or sign that would allow for mass evacuation. So
Well,
no, Yellowstone doesn't scare me at all.
I'm where I don't know
I'm more
anything
concerned
about.
about the other super volcanoes that people don't think about.
Well, they aren't in America, so they don't matter, right? That's basically how the global news cycle works, right?
And I hate it. I hate it so much because I'm like,
Where,
let's learn about water issues in the world. It's like, here's stuff about America. I'm like, no,
well, I mean, water issues on the West Coast is
it's huge.
pretty
And I
bad.
cover it constantly, but
Yeah,
I want to cover it globally because it's an issue globally.
yeah.
The,
I mean,
the
especially with climate
Southwest
change.
water issues are, yeah. I mean, I do want to emphasize that climate change and the rate at which we are using water are two very different issues. Um, People are often blaming the lack of water on climate change, and it's human stupidity that has caused the lack of water, not climate change. I want to be very clear
Well,
about
that's
that.
two things that they do at least have in common: is that human stupidity has been the root cause of both. So
Oh
that's
yeah, I mean,
that's
we've
something.
never respected the environment. Never once have we tried to live with nature. We have always tried to fight it and cage
Rise
it
above it.
and keep it in little places that we want it to be so we can live where we want. And well, that's not exactly how things are working, and it's pretty clear that we're disrupting the system. The ecosystem specifically. The world will be fine.
Well, on that note, I desperately have to piss because I've chugged like a whole fucking pitcher of water while I've been going.
Doomers!
So, one last question.
Yeah.
What's your favorite mineral?
Sphalerite. I love it.
Do you have any?
Yeah, I have a ton of it. Ah! My UV caught it. I caught it.
Oh my god. What is this freaking phasmophobia? Is this a UV flashlight falling around?
There's a lot of shit.
Chat, for any of you unfamiliar with RockitSage, obviously check her out. She's a freaking geologist and science communicator on Twitch. It's amazing, and she's a great content creator and also plays video games. But go give her a follow, of course. It was really great for her to be able to come on. And thanks to so many of you from Sage's community also who came through. Oh,
It's
it
got a
is
very weird reflectivity because it's considered submetallic, which I haven't really mentioned.
okay.
But it's got a lot of iron in this, such that it does reflect a lot of light, but it's technically not opaque. You can actually see through some of the mineral pieces, but it's kind of hard to. This is another sample that I have of just little pieces of sphalerite on the rock. And sometimes they can look really red and yellow and gemmy. And this one, if I shine light through it, it's hard to do it on camera, but you can see some little reds and yellows. I love this piece. It's just zinc and sulfur. I don't know why I'm so obsessed with it. It's just so dark, but also gemmy at the same
It looks a
time. I
little
think it's just,
like, is obsidian the word? No.
it's dark like obsidian. Obsidian is glass, so it doesn't have any kind of
Right.
structure.
Right, okay.
But it might kind of look like, actually kind of does in the camera.
I mean, it's just a very shiny, very dark
Yeah,
mineral, so.
yeah, I can see that. Yeah, volcanic glass is super shiny.
All right, well.
But I appreciate you having me on today.
Yeah,
I'm
I
sorry if
really appreciate
rambled
you
too
coming
much.
on. I was just saying, like, well, you had your headphones off, but of course, check out RockitSage and the Knowledge Fellowship, a whole gang of science and just, well, science communicators, educators, and content creators. It's great.
Yes.
And we would have done this episode a week ago. Was it a week ago or was it 2 weeks?
Yeah, it was a week ago.
Yeah, which at the time I was incredibly grateful because you accepted on such short notice, and then of course COVID. So I hope you recover from that best
Oh,
as you
I'm
can.
actually doing pretty well.
Yeah.
I'm just kind of tired.
But if you don't already follow RockitSage, of course, check her out. And
Thank you.
I think that's gonna do it. So, I mean, if you've got anything else you want to shout out or anything like that,
Just
then
go forth and share science that you learned.
there you
That's the
go.
only thing I require.
There you go. Share science that you learned. Beautiful.
Thanks again for having me, man.
Yeah.
I really enjoyed today.
People are saying in chat we'll have to have you back, and frankly,
I'd
there's
love to.
so much to talk about. Yeah, we might well have to have you back at some point.
And I know a nuclear physicist that you would love to interview.
Yeah,
So I'm going to talk to him after this.
Beautiful. I already love the sound of it. So, chat, you can look forward to that. I mentioned at the start of the stream, the podcast is supported on Patreon. So if you want to check out the Patreon, feel free and all that good shit. Speaking of, though, I feel like we should stick around a little while so I have something for the people on Patreon. But I really desperately need to piss. So I'm going to go take a quick piss if you can keep the people entertained.
Sure.
So I'll be back and we'll shoot the breeze for a little bit.